Hey guys, how are y'all doing? How's your day going? And if it's just starting, how's your night? Hope you had or are having an amazing and beautiful day. So it's been over a month I think since I made my last video. And within that month a lot has happened. Not much, the changes are not that much, but a lot of changes have happened. The first one being that, as you already know, I already have my podcast, Creepypasta with Praise, where we do everything spooky, scary, true crime, whatever it is that floats your interest in that manner. We have that. I'm going to link it down below. You can go check that out. I've also started a brand new podcast. I think I have like 4 episodes out as at the time of this video going public, and that one is called One Voice Odyssey. That one is more of a chill podcast. I just rant, complain, and just talk about whatever it is my heart desires. I think that's actually my best podcast from the two. So I've put more of a pause on Creepypasta and I'm now focusing on that one a bit more. But Creepypasta is going to be coming back shortly. What else? What else? What else? I have decided that I'm going to finally officially put a pause on software. It's not a permanent pause. I'm always going to be a software developer, but I'm going to be putting a pause on that, and I'm now focusing on data science, and I'm obviously taking you guys on the journey with me. And for those of you who've been waiting for the tutorials I was going to do on the MIT class, first of all, I got to say it, MIT is fucking hard, but it's coming out. I promise you, it is coming out. I got my app from Google Play, got to remove the week after. So yeah, that's depressing, but that's that. But on that note, I did create a new app, Rewarded View, where you watch videos and you get paid. If you're in Nigeria, you can withdraw it easily to any of your Nigerian banks, or if you're outside the country, you can choose a different withdrawal method, or you can keep it pending until when more withdrawal methods are made available. But I don't think we have any bank withdrawal method available for international withdrawals. But we do have Bitcoin, um, USDT, or you can use it to purchase to carry out in-app purchases, including displaying your own ads in the app. And I've become a farmer. It's okay. Like I said, not a lot of things, but I've become a farmer. So quite right. I don't have a house yet. Obviously, I live with my parents, but I've always been like, whenever I do move into my own place, I want to grow every single thing I eat. I know it's like giving off, humanitarian or whatever. I don't know. It's giving off that vibe. I don't know what they call it, but I can see the picture of that girl I'm referring to like that. And when I don't like a person, I mean like the idea in my head. I can see it, and that is not it. Mine is more of the sense that I don't trust human beings. Don't know what the fuck you're putting in my food. Plus, because every single thing in Nigeria has just become unnecessarily expensive. Doesn't make sense. So I would like to grow every single thing I eat, so I know what I'm eating, and I'm not paying nobody to be able to get food. So maybe I'll put a few pictures up here if you guys want to see it. It's still new, so a lot of them are just starting to sprout. Don't judge. I have onion, green pepper. I think this green pepper that will end up growing to red and yellow pepper. I don't know. I'm a new farmer. I have normal peppers. I have chilies. I have tomatoes. Tomatoes just like growing. I think I just planted it 2 days ago, so it's very very tiny. You have to strain your eyes to see it. And I have watermelon. The watermelon is crazy. So last night the watermelon were literally barely visible. Came back this morning, we're almost growing out of the plate. Checked it again in the afternoon. I think I've already started growing out of the plate. So the watermelon is growing very fast. And funny enough, I don't eat watermelon. I hate watermelon, but everyone in my house likes it. So I'm doing it for the family. But yeah, so if you have any tips on how I can better grow all these, leave it in the comment section below. And if you want me to vlog my journey, because it gives me so much joy when I'm there. I know quite right, I'm probably doing rubbish. Oh yeah, I also have pineapple. Yeah, I know I'm probably doing rubbish, but it's what is the word? It's it has a type of zen. I don't know. It's just relaxing. I enjoy. It makes me happy, especially in the world we live today. It's nice that you can find happiness in something. But yeah, like I said, I've entered data science, and so data science. If you want, let me just give you. Should I drop a quick roadmap? So if you're watching this video, you mustn't have like before, although this is practically the first video in the whole roadmap, whatever. But yeah, if you just want to learn NumPy, yeah, if you don't know which is weird because that's the name of this video, this tutorial is about NumPy. That is a numerical Python. So, but before we jump into it, let me just brief you on what we're going to cover in this our journey to data science. So, first thing you need to choose the programming language you want to use. I don't know if there are more, but the two programming languages everyone always say about is Python and R. I'm obviously a Python developer, so I'm obviously going to choose Python. I personally don't know shit about R, but if you ask me which language you should choose, if I watch my video, I'm obviously going to say Python because I'm not going to be doing any tutorial on R, at least not yet. But um but the say R is mainly based on statistics, and Python cover like all this your math plub stuffs, all these like almost all these other math calculating whatever stuff you do. You can do that with Python, including machine learning. So Python is once again, and I'll always keep saying it till the day I die, the best programming language in the world. So if you are if you don't know what programming language to choose for this journey, Python it is of the um next thing is more of a mathematical thing we need to learn statistics and probability. And after that, we're going to go into data manipulation and visualization. This is where most of our Python libraries will come in hand, like Panda, NumPy, and so much and so forth. So we're going to cover every single thing here. Then we're going to jump in and just tease ourselves with a little of machine learning. We're going to work on so many projects, both practical projects and just projects to test your knowledge to test what you have in mind. Then we're going to go into more of a real life work field type practicalization. And hopefully by that time, I would have actually gotten a job as a data scientist, even if it's a data analyst, so I can have more of an experience when I'm doing it. Although I'm going to start freelancing at it before we reach there. So up the fingers crossed we'll reach there. And finally is to just keep staying updated. Tech is an ever growing field. So we learn together, we grow together. I'm always open to see and answer any question you may have. And yeah, feel free to ask. So the first part, like I said, is learning Python. The very first thing we need to do is understand Python, learn the basics of Python. All of this, which I've made so many videos on. So just head over to any of my Python playlists that are available, which is practically almost every single thing on my channel. Pick whatever one speaks to you. But if, because I know when I did most of those ones back then, it was a bit, and now more, maybe if you want a more practical approach, talking on those basics, but with a more mature idea and a more data themed vibe, which is practically nothing. It's not going to be that different. But for a more experienced approach, I also feel that like maybe the way I'll position out better. I mean, this video would be the tell, but if you want that, you can let me know and I will do a Python basics video once again. I think that will be like my 100th one. Um, we're also now going to go into all the libraries for data science, which we have NumPy, Pandas, Matplotlib, and Seaborn, and also this scikit-learn. We're going to do cover and enter into all those what do you call it libraries. One thing you should just keep in mind is that most of all these libraries inherit from NumPy and NumPy inherits from list. So it's not compulsory, it's not necessary, but just part of a prerequisite for this, just have an idea of how Python list works, some of their manipulations, like just things you can do with a list, which is not hard, I promise you. It's really not hard. I'll see if I have a video on my channel that just talks about list only, and I'll link it so you can go watch that first. But like I said, it's not compulsory because I'm still going to teach every single thing here just to have a better understanding. Then we're going to work on some projects, but not just basic projects. We're going to work more on the projects that involve us analyzing data sets, creating visualization, and building. I was like beauty, building predictive models. We're going to jump into all that sooner than later. So don't panic, don't fret if you don't understand what I'm saying. I promise you, before this year ends, you are going to be a data scientist, hopefully. But yeah, shall we jump in? Let's jump in. Okay. Oof. The class might be a bit disoriented because I'm a bit disoriented, but I promise you by the time when this video is ending, you would be on track. So I'm just going to I'll be randomly training some few points I feel you should learn because I had like made out my notes, which is what I have here in my hand. It's not long, it's this long notes. My handwriting is tiny, so I feel so maybe someone else wrote it will be a bit longer, but I have one, two, three. So we have just 6 pages of this long notes. It's not that much. But as I was making my notes, I felt like there were some things I didn't touch on, so I was like asterisk it. So we're just going to hopefully I find a way to say to make it make more sense to you. Because I like this is one mistake I keep making. I assume people already understand it, which is wrong. Because if I'm just training the point randomly to people understand, it's not going to be as confusing as. But I promise to do my best. If I make this video and it doesn't go well, we'll remake the video. YouTube is not running out of storage anytime soon. Let's start with one of the most basic question I would like I feel that you should know before you jump into NumPy. Do you understand what a matrix is? You know, this stuff that everyone did. I did it in secondary school, I think. Yeah, so we all did matrices. There's so many um functions and like things like the transpose, determinants, this and that and all those stuff that concern matrix. If you want me to do a course on matrix, this one is even if you're not planning on learning this, maybe I should do that. Yeah, I should do that. I should start going back into secondary school math. I feel people like watching that. So if you don't understand matrix, maybe just brush your memory on it a bit, but it's completely not necessary just so you can have a better understanding. But matrix is a rectangular array. If you don't know what an array is a collection of different elements. Is it elements I'll use? It could be a collection of integers, floats, booleans, whatever your heart desires. But array is a collection, so it's like a kind of like a list. A list is an array. I remember when I was doing C++, we called them array. Then I jump into Python and we just address them as list. But they're basically almost the same thing. So a matrix is a rectangular array or a table of numbers, symbols, or expressions arranged in rows and columns used to represent a mathematical object or a property of an object. Comprende? So now, NumPy, which I've already mentioned earlier, is numerical Python. It's a Python library that deals with creating of these matrices or whatever. But not just that; it's so much broader than that. But if you just want to have like a way to just relate it to your head, just think of it as that. Just think of it as an advanced way to work with list. And unlike list, I mean list can do it too, but NumPy makes dealing with multi-dimensional list better. What I mean by multi-dimensional, you have one-dimensional list when you have something like, let's say we have a list and the list is going to be just one list. Where's my square brace? Just one list, and maybe we just have one, two, and whatever element it is. That is a one dimensional list. Now a two-dimensional list is the list is where you have two lists nested in another list. What do I mean by this? So you guys remember um when I covered nested list, which is in my previous videos. So let's say we have this list which you already have here, and then we get another list and we nest more elements into that, I guess. So this is a two-dimensional um list, and I'll take your guess on what you think a 3D list to be. So it's almost the same thing. Is when instead of just having two lists nested in another list, you have two lists nested in each of these two individual lists nested in this list. So the way we have this one here, let me just do this quickly. I'm coming. So so the way we have these two lists separately, we're not going to get two more lists nested in each of them. Fuck, I just did. Okay, this way, this their suggestions is tripping me. Okay, so we're going to just have two more lists nested in each of them. Then we cannot have elements in them. So that is a three-dimensional list. So why use NumPy if list works just as well? Like I said, NumPy is easy to function. It makes it more easier to manage some of these properties. It's also built in with so many predefined functions that helps you carrying out certain of your mathematical operation at an easier pace. It consumes lesser memory than list. You don't need to be type checking each individual element or during each iteration. It uses contiguous memory. So for example, when you have a list holds pointers, and a pointer you could have one that is in at a particular place, have another one that is like couple spots after, but what numpy does, it takes the very first part, like it will first check to be sure, okay, I need to have 5 bits. Do we have 5 bits available here that are side by side, which means it's going to be lesser work for the memory, since you just need to know where it's starting, and from the amount of bits required, you just count it down and you know when to stop. And it also uses a more effective way for cache utilization. But yeah, like I said, a number is just a list with more, it's just list on steroids. So where are some of the applications where you may need this? Like I said, so many other of the libraries which we're going to cover make use of NumPy. It's used in mathematics, it's used in plotting, and it's used for back end and machine learning. So let's get into the basics of NumPy. First things first, make sure you have NumPy installed in your system. So you're going to open your command prompt or your terminal, and you're just going to run pip install NumPy. I hope you can see it down here. Once you run pip install NumPy, just press enter. If you need to upgrade your pip, upgrade it. I need to upgrade my pip, so let me upgrade it. Let me just connect to the internet quickly. But it's not necessary, it's not compulsory, it's not something you have to do to survive. But if you do it, no one is gonna hold it. So once your numpy is installed, you'll be able to effectively use it. That was my big sister. Okay, so let's just wait for this to finish. Uh, okay, so now that we have everything installed, first things first, before you work with anything, if you remember when I talked about importing, you can import specific functions from a library, you can import the full library, and you can also import a library as. So that's what we're going to do. We're going to import, we're going to import numpy as np. So it will be easier for us to access it. And once we have that in, the very first thing we want to do is to be able to actually create an array. So how do we go about this? Very, very easy. Let's say A is what we want this array to be called. A is going to be equals to np.array, and we'll have our bracket. Within this bracket is now where you're going to create your list. If you want it a one-dimensional list, a two-dimensional list, three-dimensional, wherever your heart desires. We're just going to use this one-dimensional to make it easier for us to sort of like manage. All right, so next thing would want to know how to do is how to get the dimension of an array. Getting the dimension is basically just, it's very easy. Let's just print it out so we'll be able to see it. Just going, you remember how to print in, well, my voice wrong with my spelling today. Print, we're just going to call the name what we called list dot nd, and just save it. If you are running it manually to run, if I don't have, just realized I've not run the Python file in a long while. You just do Python space the name of your file, including the .py extension, or if you are using an advanced what is it called, IDE or code editor, you can just press the run button, which I'm sure most people have noticed. I'm no longer using Visual Studio Code. Why? Because I just fell in love with the new version of PyCharm that was just launched. But yeah, here you can see it's 1D. So if let's say we were to change this, if you are creating multiple lists, don't forget to always include the comma between the two lists. So we have 5, 6, 7, 8. Let's save that. So now we should get 2. Perfect. Okay, and what else do you want to know how to do to get the size of the matrix? That is like, is it a 2 by 2 matrix, a 3 by 3 matrix? Where 2 is the row and 3 is the column. That is, we are doing 2 by 3. So you all remember row. If you're in Nigeria, row is not the way you use row in school. I'll put a diagram. A diagrammatical representation on the screen so you can know which is row. But row is horizontal, column is vertical. So you have row, the column. So if we're using this one, let me get a more better presentation for you so you can see that for yourself. Let's what should we use? What should we use? Let's create a little spreadsheet here. Let's get a new spreadsheet for ourselves. So these are spreadsheet here. We have one, two, is this saving? Okay, three, four, right? Then I think the next one will now just continue 5, 6, 7, 8. So here, starting from this place where we have one, this is the first row, this is the second row, this is the first column, second column, third column, fourth column. So hence this is a 2 by 4 matrix. So um if we are to get the size of it, so if it's a one dimensional matrix, which is also sometimes known as a vertex, I think they usually call it, but if again you just get one figure. But if it's to more than one dimensional, it's going to give you the row and then the column. So when I use working with when you're working with numpy, we call that the shape. So it's going to be a dot shape, and if we run that, that should give us what I said it was going to give us, a 2 by 4. So it doesn't change, it keeps going. Even if it's a 3 dimensional or 4 dimensional, life continues. Next one, to get the data type and the memory used. So data type, when you're working with data type, if you guys want to see, I have a blog article. I will leave it linked below. I covered even more things because there is like not talking, because it's more like, well, I finished my notes before I read the blog, so I have a little more extra stuff which we are going to still cover, but I'm just trying to cover some of the basic things you need here. But enough diversion. When you are working with data, you remember when you're checking data type plainly in Python, it will just give you int, it will give you float, stuff like that. But the way the data type here is going to now present itself is going to give you first the data type, which maybe is int. Then beside is now going to be a number, which are the number of bits that is being occupied. It could be 8 bits, 16 bits, 32 bits, 64 bits, and so on and so forth. But let me just give you a quick explanation of how these bits function so you could understand it in case you see it. Okay, so this is going to be the most layman way I can explain bytes and bits or whatever to you. So here is like a basic categorization or whatever. It's not the most detailed, but these are just some of the most popular bits we make use of. So we have 32 bits is always going to be equal to 4 bytes, 16 bits is equals to 2 bytes, 8 bits is equals to 1 byte. If this is true, that means in terms of conversion, 1 byte is equals to 8 bits, which signifies 8 binary digits. And you know, binary is a collection of numbers from 0 to 1. So a binary can have its lowest value as zeros in 8 places and its highest value as ones in 8 places. Now, basically, what this is saying is that if now we were to now apply this into some of the other ones, let's say 16 bits. Let me readjust this here. Sorry, pardonnez-moi. So 16 bits is equals to 2 bytes, which means equals to 16 binary digits, which is going to now mean, if I using the lowest possible value, is going to be this. So why is like basically everybody saying, like, if you're in terms of when you're going to buy, for you always be like, get the highest storage. But why is it that when should you use, like, because we're going to soon jump into specifying the amount of value you want to use when you're initializing an array, which we already know how to do using np.array. And first of all, I didn't even mention the reason why we're using np is because we imported numpy as np. If we just imported numpy, we're going to use numpy dot. If you do, which I the one I mostly do all the time, is import with asterisk to just do array. But the reason why I'm not doing, because some of the numpy functions are already existing as other functions, just so the system will know that the function we're referring to is the one that comes directly in numpy. If you get a bit noisy, I'm sorry, because it's hot and I need my fan. Okay, so where was I? Yeah. So I'm sure it's just better for you to just declare excess storage. But the reason why this will not now be better is because what if you are working with a limited amount of storage, especially when you want to compute something so little. So this 8 bytes in decimal numbers is from anywhere from 0 to 255. So which, if you notice, if you are checking, like, okay, if you watch with, I think one time when I mostly use it is when I'm working with okay, HTML, when you want to limit the amount of inputs the person can do. So you now I forgot how to teach just because I can't remember. Oh, damn. Oh my god, wait, I've actually legitimately forgotten how to do it. I'm like trying to jog my memory. I know when I'm creating forms and I would like to bloody. Damn, give me a second, because we're going to remember this today. Oh, sorry, no, that was my problem. I was thinking of HTML forms. No, in Django models. So when you're working with Django, you can specify the amount of length, which is using max length to specify the amount of length you want the user to be able to give. And if you've noticed, when I'm usually creating, I'm always going with 255. I think it's just a habit I inherited apparently. But that 255 is the max amount of value an 8 binary bits can contain. Quite right, yes, the 32 and the 64 are going to hold more than the 8 and 16 would. But if what I'm doing, which is most of these low temp projects when we work on, is always going to usually fall in between 8 to 16. But yeah, on that note, I don't know. Let's check. I can't remember the default the system uses. But yeah, to check it, we're just going to do d type. Let's save that. So we'll see the default that the system gives us. So we're seeing int 32. Although my computer that I'm currently on is a 64-bit system, but the default most system is a 32-bit. And for like example, this test run we're going to use is going to just be a waste of space. It's completely unnecessary. So what we can do is to specify the amount of storage you want to occupy, so we'll not have any garbage waste or whatever. Just have a comma after you have called your list, after the basic things that is usually enclosed in there. You can see it's already suggesting it for us here, although I don't know why the fuck I'm saying np.float. Maybe that's the way people do it, and I've never done that in my life. So I'm just going to do the same thing that I did here. Type d type, which is the way we check for the data type, and we're now going to specify what we want. If we want it to be an integer, if we want it to be a float, so let's just do int, and let's just go with 16. Let's save that and let's run it once more. And you can see now it's an integer with 16 bits of memory occupied. Okay, next thing, what if you want to get the size? The size is just all this whole bits or whatever stuff that I just explained for you. The way we're going to do that is to just put item size. Let's save that and let's run it. Two. So why are you seeing two? So the two here is now, let's come back to this our beautiful PowerPoint presentation that I made for you guys. 1 byte is equals to 8 bits, 2 bytes is equals to 16 bits. So here we initialized at 16. So hence when we're getting the bytes, it's going to be this. So this one is showing it in bytes. But I'm saying bytes, that is bytes. And well, have I been calling everything bytes? This is 16 bits, like bits. So it is 16 bits, and item size gives out the result in bytes, which is bits. So 32 bits is equals to 4 bytes, 16 bits is equals to 2 bytes, 8 bits is equals to 1 byte. Then, but what we want to get the total amount of elements, the elements are the individual contents of our list. How do we do this? So it's almost the same. So we're just going to say item size. Sorry, no, we're cleaning up the item, we just need the size. So item size gets the memory. But I feel when they were making this, they didn't think it through. Vowel size gets the total amount of elements here, which is 4. 1, 2, 3, 4, 5, 6, 7, 8. Why did I just call 4 just now? Because there's no 4 anywhere, I swear. It's 8. Then what we want to get the total size. So the total size is this size multiplied by the item size. I don't know why. So you can literally do that manually, or you can be an optimized and an efficient developer and go n bytes. We have 16, so that is 8 times 2, which is going to give us 16. So at this junction, I'm going to allow you to just marinate it in your memory. I know I have not come. There are so many other things you can do. We're going to jump into a few more, but in the description, I'm going to leave some external resources that have more of all the NumPy documentation, which you can go out and check out for yourself if you want to. But I'm just kind of giving you like this so you have an idea and an understanding for it. But yeah, let's go into accessing and changing the elements within a NumPy array. Okay, so the first thing is to get this because you already know how to print out an array. If you want to print it out, it's basically just saying print and the name of the array which you would like to see. Will print that for you. And so you can see that I even tabularized it for you in the matrix form. But what if you want to get specific elements? So I was going to initially just change to one list so it'll be easier, but we're trying to make sure you understand it fully. And in a sense, I mean, I don't think it is, but in a sense, I guess working with nested elements is a bit more complex. I've already explained how to access nested elements within a list, which is the exact same thing. So let's start with the basic. If I want to get, so now if you indexing in list, we have in indexing in Python always starts at 0. So when you are thinking of it, let's check a diagrammatical or can we, are you understanding it? Will you understand if I'm explaining to you like this? Please do. So think of this first section which I've highlighted as 0. Okay, no, okay. Let's do this. Let's do this. Genius praise is in action. Let's have an element here. Let's say n1 is equals to what we just copied. And in here, we're going to have n1. Should come to think of it, why is nobody explaining like this? I feel it's so much easier when you explain it to beginners. This is going to be our n2. I'll say n2 is equals to this. So now this is the array that we're trying to access, right? So in the array, we're going to say n1 we're going to say n1 here is our is at index 0, n2 is at index 1. So if you want to access something that is stored inside n1, what are you going to do? So if you want to access something from a list, you enclose it in a square brace. And so since we want to access from index 0, which is over here, we're going to now say 0. So that is now this whole one here like this is out of the picture. What we're now trying to do is access this here. So it's only this thing we can now see. This is the only thing we have access to. So once now get a specific element inside this, let's say we want to get access to number 2. 2 is our index. We have 0, 1, 2, 3. So 2 is at index okay, just sitting now 1. So outside the square brace, we're not going to enclose it in or nest inside this exact same bracket. We're going to call on that bracket, and this bracket we're now going to call the name of the index which we're trying to access. So do you understand? So let's just put everything back as they were. But yeah, hopefully that helped you understand index, and that's the easiest I can do. So once again, we want to first lock out one and just only have access to index 0. Then we want to now access the second element, which is at index 1 for my element. And hopefully, if what we have done is correct, it should print out 2 for us. Perfect. Do you understand indexing? I feel this this is probably the easiest way I can think to explain indexing. But yeah, that's just it. And even if you had more nested elements inside here, it's still the exact same approach. Just locking out, just be grouping. Don't pick from the center. You're doing it from outside and you're working your way in just the way you eat. I don't know. But whenever you're working from outside and you're coming in, you're not working from inside and going out. Hopefully you understood. Next one is to get a full specific row. So all these other ones are just ways to mess around with indexing. So if you want to get a specific row, we already mentioned row and column. Let me print out A again so we can see their beautiful representation. Or should we go to our let's go to what we made here. So this is our first row. So what if we want to get this whole row like this? Give me an idea of what you think we can do. I'm not going to maybe go off my head and try and think of. I can only think of one way you guys are going to approach it. I feel if you guys are asked to get a row, let's say I want you to get the rest of like let's say I want you to get first row for me. I feel your approach would be to just print out this. Let's try it and see it. Perfect. Or another approach you can use is slicing. What is slicing? Come, let me get a beautiful explanation for slicing because I said, God, if you tell me to explain it, I'll say slicing is just a method you can use to access multiple elements in a list, which is correct. I mean, that's what slicing is, but let's check. What is slicing in Python indexing? Slicing in Python indexing refers to the technique of extracting a specific portion or segment of a sequence like a list, string, or tuple by specifying the start and the end indices along with optional steps. So yeah, those steps usually contain a sequence of start, end, step, where step is the amount of times you want it to jump. But yeah, so the way it's usually going to be when we're slicing is you have um what am I skipping? I don't know what it is. Okay, sorry. So let's assume A is a list. Slicing here, zero will be the index where everything should start from. Then the next is going to be where you want it to end. Let's say you want to end at the second index, which is 3. So by default, the step is using is one step, which means it's just jumping to the next. It's not skipping anything. But what if we want it to skip? The third element you now input is now how many skips you want it to take. Yeah. But especially now when we're now working with multi-dimensional elements, and how it access it, let's say we want to still access this number 2 here. The first thing we're going to do is call oh shit, sorry, I just misled you people. Forgive me. Because I was wondering the answer I wanted to get wasn't slicing you don't use comma. Pardon me. Slicing you use what is the name of this double dots? This stuff. Yeah, that's how you slice. That's how you slice. Let me clean this comma at the back here. Sorry, forgive me. My head is getting jam packed. Yeah, that's it. So like now you're saying why is it like this? Because we are accessing we are dealing with multidimensional and like I said, if you want to just call it within here, we're accessing both elements, that is the first element, second element. But if this was now applied in the sense that we had our zero here, then we now had a second element here and we now applied this stuff which I just did for you. Now we save it and we roll. Now it's only going to access number 1, 2, and 3, which is in the very first list. So why are we only stopping at 1? Because there's something they call it where like the last index you place here, the end index is not going to be accessed. It's just saying that once you reach here, stop. Don't even access me. Just stop. Being basically saying stop in front of me. So now, one thing I've noticed is that the way I'm approaching this now, I'm treating it as a list, and that is not what we're trying to do. We're trying to treat this as a more advanced form. So, if we're doing it that way, how are we now going to access it? We're going to access it using rows and columns as every professional mathematician is. So, this is where we're now going to actually apply that comma stuff I was talking about using so where the first element before the comma is the row and second element is the column. So where is our think of it as a spreadsheet. So we want to access this number 2. Number 2 is at the first row, which is row 0. So if we come to our beautiful place here, we have row 0. and then it's at what column? The first column, second column, which is row one, which is what we have here, 0, 1. And if what I've done is correct, we should get number 2. Perfect. I'm hoping you are comprehending and you understand what I'm doing. Now, the way I approach it, which I think you can, same as why you just applied, you can also implement slides in here. If yeah, I said I wanted, if I want to get a full row in slicing, if you want to get every single thing, just don't put a start, don't put an end, just put those double dots here, Control S, save it, and the sorry, run it. And the way we apply this, the way you can just continue applying it, implementing all these slicing techniques. I'm not here to teach you this, so you can go and check on some of my other older videos to understand how you can implement all these stuff better and implement it for yourself. What else do we want to try? So if you want to change the value, change the value. Once you have already understood how to access the value, changing the value shouldn't be that hard, I believe. So let's say this is the exact same value you want to get change. So if you want to change it, we're just going to say just the way you called it here, when you wanted to print it, is the exact same thing to call it 0, 1. Now we're just going to equate a new value to it. But let's say you want to equate, you don't need to do all this empire anything, just put in the number you want. Let's change it to 22. And now if we access it and print it, we should get 22. Perfect. So once you know how to access it, working and manipulating the data is honestly not going to be hard for you. Okay. So next is initializing different types of arrays. So that is where you have like all zeros, you have all zeros is when we want an array that every single element in the array is a zero. So how do we go about this? Let me just clean off everything we have here. Oh gosh, I think I'm hungry. But np does, and we'll just call zeros. Next, we're now going to put in the size of what we want the array to be. So that is okay. I think it's already putting it here, extending for shape. Remember when we access shape, it will tell you the 2 by this, 2 by that, by that. So then it showed only 10, which means the vertex, which means like only one row, one row. Yeah. But now we want it to have a row and a column. So we just let's include that in a brace. And then we're going to have 2 by 3. That means we're saying 2 rows and 3 columns, but everything's going to be zeros. Oh, sorry, I'm not putting anything inside the data type. Should we still, let's just clean out this. Let's clean out this. Let's see it. Oh, sorry, I'm accessing a specific element. Let me clean that out too. Because the part is like, praise, what are you doing? Well, it's just me being praised. Yeah, so it's a 2 row matrix with 3 columns, and you can make it as high as your heart desires. I promise you, no one is stopping you. Go crazy with it. Next one is if you are working with, you want everything to be all ones. So you just almost the same thing, you just put ones and you run that. Then what if you want to use a number other than the basic binary numbers? How do you go about this? It's very simple. So instead of doing twos or threes or fives, you're going to do full. But now there's more of a twist. So the first thing is going to be the shape, which is what we already have here. Then behind the shape is the value we want to use to fill it. Let's use my lucky number and let's run it. You're seeing fill value. So you're seeing why I'm liking PyCharm. But I'm sure you will find the right library. Visual Studio Code is going to get it for you. But I like PyCharm. I'm now falling in love with PyCharm. I'm sure it's going to change very soon. But that's the first one. The second one is using the full like method. So using this full like method, what you are going to do is, let's say we have sure guys, I'm going to have to start. Can I just explain it to you? Okay, no, I'm praise your you're just being lazy. Let's create another matrix here of our choice here, B, and let's say B should have a shape of 2 by 2. So let's have remember how to create it. Np dot array. You should be saying it to me as I'm typing it. Let's do the one we just created earlier. We have our brace and we have our first blah, blah, blah. We have the second one, we have our comma, we have the third one. So the first one should contain 1, 2, 3. The second one should contain one, two, three. So okay, now let's use different elements. I feel four, five, six. Okay. So what is the shape of this one? This is a two by three, right? So if we now want to get the shape here, so if we use just if we're using just full here, what we're going to now do is say call the name of the new array we're trying to access, which is b dot. We want to access the shape of b, so it's b dot shape. We'll get the shape value of b and in place it there where we have our current value. What did I do? Was never closed. Oh, sorry. Oh, it's tried. Why did I not notice this was highlighted red? Or another approach you can do is do full underscore like. Then if we're using this method, we can now easily clean out the shape, since we're just saying full like is automatically like saying b dot shape even though you don't put the shape there. Either way works, whatever rocks your boot or whatever floats your boot. What else? So now working with random. So remember I've worked with random, so this is almost the same thing, but you don't need to import random for it. I guess random functions are already automatically implemented in it. But if you want to create random functions, either a random integer or whatever, but first we're going to work with random decimals. So the first way we can do this is let's just clean this out. So if you want to create random decimals, we'll just say np dot sorry random dot rand. Then we're just going to close it. So the first what we're going to now, because we're not calling the values, we're just going to put the rows and then the columns. So let's still continue with the two by three, which we have already started. And if we save it, it's going to generate random values for us. And for every time you run it, if you pay attention, I mean, the numbers are too hard for you to keep track of, but if you're paying attention, you will notice that the numbers are different. Or kind of like the full like function which you just did, we'll do random dot random random underscore simple. Then here is what instead of calling the rows and columns ourselves, we're just going to call the element that has what we want, which is b, and this one we're going to include the shape, so b dot shape. All right. Then next, we want to get random integers, that is like random whole numbers. What we're going to do is still almost on the same thing, but let's just clean this one out. So np dot random dot you should already know what's coming here. Rand int rand. What is that? Int. So now this one is going to be a bit more complex. There are more values that we're going to give in. The first one, as we do with every random integer, is calling the start value, but it's not compulsory. If you don't call the start value, it's automatically going to start at zero. But let's say we don't start zero. Let's say we want to start at whatever number I just imputed here. Let's say we want to start at, then we'll have our comma. Then we would have the size of what we want, which is going to be 2 by 3. Also, you can also add the end value, which will be the comma that will come before. Okay, I see this here, low high. It's going to be the comma that is going to come before the this stuff. So let's just add an end value. What value did I put? 1, 2, 3, 4, 5. Let's put 5. 1, 2, 3, 4, 5. Have your comma, control S, and let's run it. So there, and for every time when you run it, a new value is automatically generated. So now generating an identity matrix. For those people who don't know what an identity matrix is the n times n square matrix with one. So like that is like a 2 by 3 matrix where every element is all ones on the main diagonal and every other thing apart from there is zero. So let's say where's my thing? So this is our okay, this is very small. Let's do the actual 2 by 3 we're using now. Wow. It's 16, but let's just clean out this one, I guess. Okay, so our main diagonal, let's assume is 1 and 6 will be 1, here 2 will be 1. Then every other thing would be 0. Doesn't allow me to select and correct everything. I think Excel is boring. Okay, something kind of like that, I guess. Oh no, let's just create it. So creating an identity is very, very easy. See me being foolish. An identity matrix must be a square matrix. A square matrix is a matrix that both the rows and the columns are identical. And not because I was like, that's looking oddly weird. So if we want to do that, it's still going to be our what did I just do? It's still going to be our np dot identity. And since the rows and the columns are the exact same, all we need to do is just call one of the value, whether it's the rows, whether it's the column. So you have it there. So I think this should look exactly like what we have over here. Perfect. Um. Oh, yeah, okay. Sorry, I was saying vertex. They are known as vectors. Vectors. So what else do you want to do? Okay, this one is just a note because I was noticing that some of the other videos I was watching were giving notes to this. I guess some people don't know this. If you are copying using b equals to a, this means that b is pointing to the locate to the same memory as a. So if b is modified, a is going to automatically be modified since we are using memory location. But if you just want the content of a, then instead of doing b equals to a, you're going to do b equals to a dot copy. That copies all the elements of a and moves it to a completely different memory location. Now let's get into mathematics, everyone's favorite subject. Well, I'm not going to do much. I'll leave a link where you can find out more of the other elements just so you can understand how to apply it. And after that, we'll round up. So um let's talk about basic arithmetic. So let's make this thing a bit more easier for ourselves now, shall we? Let me clear this out. I keep falling behavior. I will be just like that. So we have our basic array here. So we want to carry out all this basic iteration. Basically, when we do something like we say print a plus 2, where plus is literally any arithmetic operation, what is going to happen here is going to iterate through all the elements that exist in a, and it's going to apply the action on them. So you have 6, 7, and 8. So you can put any other thing. So for basic arithmetic, is literally very easy. You can now also make use of, you're familiar with the math library, so there are still some other math functions you can use. So if we are doing that, let's say clean this out, there's enclose this in parentheses, and what we're going to now do is, let's say we want to work with sign, np dot sign, put in, it's going to find the sign of all those numbers, and there are so many other mathematical operations that can be carried out on it. Then digressing a bit further, we're going to now watch jump into linear algebra, which we're going to focus more basic on in another video. But linear algebra is a branch of mathematics concerning linear equations such as linear maps and their representations in vector spaces through matrices or matrix. So if you want to multiply two matrices, this one is basic matrix facts I'm just quoting now. If you want to multiply two matrices, so I should pronounce this stuff for me. If you want to multiply two matrices, the column of the first one must be equal to the row of the second one. So if the first in this basic math, so if the first one we're working with is a 2 by 3 matrix, is a 2 by 3 matrix, then the second one must be a 3 by whatever the hell we want it to be. It doesn't matter. It just must be the way I used to remember it in secondary school, because for some reason it was confusing me. I was just saying when they kiss each other, they must be the same number. So like I told you, I was just speaking a bunch of different facts because I was like, I'm going to refresh my memory on matrix. But yeah, once you've gotten it, so let's create two matrices now, shall we? So this is a we're creating a 2 by 3 matrix. You keep saying your voice around me, you're waiting to react. Behavior, I want it just like that. Ready if you want. Three is the exact same figures. Is that just me being lazy? It's just me being lazy. So if you want to multiply these two matrices together, we're going to have np dot matmul, that is like the short form multiply, and in bracket the way we're going to now call the two matrices which we want to multiply together. So now this should give us an error. Who can guess why? So the for this one here is a 2 by 3. So if I'm multiplying this one must be a 3 by 3 matrix, which means we need to have an extra element here. Okay, why not? And yeah, is there another thing? Okay, this one is just an extra note. It's not compulsory because we've not jumped into matrix yet. But determinant. So determinant of a matrix is a scalar of is the scalar value of a matrix that is a function of the matrix. Oh, calm down, no, there's a person. Yeah, I don't understand why I reject. Okay, Google. What is the determinant of a matrix?
According to Wikipedia, in mathematics, the determinant is a scalar value that is a function of the entries of a square matrix. The determinant of a matrix A is commonly denoted that A or A. Its value characterizes some properties of the matrix and the linear map represented by the matrix.
Okay, so mathematically, oh gosh, is there like a way? Don't I have like pins? I feel pins would be easier for me. Okay, let's just no, let's use pins. She just appears like bloody damn. Okay, so if we're doing it mathematically, forgive my handwriting. We'll have DT, which is the short for determinants. We'll have a bracketed signifying our matrix is going to be A, B, C, D. This is going to be equal to, I think there was this modular they called it, I can't remember. A, B, C, D. Then we're now going to cross it like this, starting with the main diagonal first. So we're going to have A, D minus B, C. If you cannot see it, pay attention, use your ears. Listen, don't see it. Nobody needs that in their life. So, long story short, let's have the determinant of this first. Should we give ourselves, let's give ourselves a 2 by 2 matrix. Clean out one of the values. Clean out one of the values. So if we're getting the determinant of our matrix, is going to be, since this falls under linear algebra, it's going to be lin og. Then we're going to, yeah, since already even giving us some other suggestions. But no, we want to get the determinant. You can, I think I will scroll and see some of all these other ones. So see some of them there. But no one's doing just get as the internet said, and then we're going to have the elements which we want to get the determinant of. So let's calculate this by ourselves before we use calculator. Ooh. So if we what is the value we use? 4514. 4514. So if we cross it using the main diagonal first, let me just open my 4 times 4 is 16 minus 5 times 1 is 5, so you should get 11. I cannot even find calculator on my phone. Luckily, it's an easy number. So if we run this successfully, either this is correct or our math's correct, but we should get 11. Perfect. And I guess he gave dashed us some extra decimals. But what else? Okay, let's jump into statistics because that was part of the subject the mathematics we mentioned earlier. Which we still have one page to go. Okay, statistics. So some of the main things we do in statistics is means, whatever. If you want to get the minimum value of something, that is the smallest value or something in a list, you do this by using MIN. So save it and you should check what is the minimum value overall. I think that should give us one. Okay. Now, what if we wanted to get the minimum row, not as an individual value, but the row? We now start making use of things called axis, and this axis can be implemented in any other aspect of the life. Of the life. So if there so there are two numbers. So now this one is showing us zero. So if we use axis equals to zero, it's going to pick the row, like the complete row where all its values are lowest. So if we run that, that should be worse. Which one should it indicate? See me covering that. I was coming because like me, I want to see it by cover it, but like you guys can see because you guys are recording the screen. But yeah, 4 plus 1 is 5. 5 plus 4 is 9. But what if you wanted to get the lowest value from each individual matrices? Well, you sorry, each individual rows. What you're not going to do, instead of 0, you're going to use 1. If you save each one, it's going to give you a new list. Perfect, sorry. And this thing, like I said, can be applied to any other. So I'm just saying because I'm going to clean it up so I can introduce you guys to a new function. If you want to get the maximum value, that is just max. And likewise, you can apply axis here as ever you wish. And axis can also be applied in many other places aside from just finding minimum and maximum. I'm just letting you know. Now, like also, okay, for example, now here it can also be applied here. But what if you want to sum up a matrix, please add every individual. That is 9 plus 5, that is 14. Oh my god! Just watch me get you wrong. Watch me get like like these are simple numbers, okay, but it's just like I've not done anything mathematical in a while, so I'm just on fire. Why is it showing me an error? Np.sum. Well, okay. I mean, because I was confused. Why am I seeing danger? 14. So what I was doing, like I said, you can also apply axis here, however you had desires. What else do we want to do? All right, so let's just we're just going to jump into one more thing I feel we should just have. Okay, two more things I feel we should just have at the back of our mind before we now round up this particular one. Like I said, I'm going to still leave more access. So now you've already understood the basics of how it works. I'm sure even if you are just giving the elements, you are not going to find it hard to understand how to implement it. So first one, if we're loading from file, I don't have any predefined file for you guys to try yet, sorry. But we can say A is equals to NP as usual dot generate, that is GEN from, okay, I see generate from TXT. Then what we're going to have here is going to be the file name, which is going to be included in parentheses, the file name with the extension. Then after that, we're not going to have the delimiter. How do you spell it? I'm trying to wait for them to pop it up. Delimiter, okay? Which is going to be the separator. So because you have like a list of elements, you're going to choose what you use to separate each individual element in the file. That is the first one. Next one is if you want to change the data type. So you just put the element name dot as type, and you're now going to put it just the way it appears when you are getting the d type. You're seeing they're giving us already the name of the data type with the amount of storage occupied. And yeah, yeah. So we are going to work on some more projects in the video which is following this one. So you want to see that, don't forget to like, subscribe, share, comment, and let me know if there's any other thing you want me to go forward on, or maybe something that you tried seeing on your own and you still don't understand and you'd like me to touch on. But aside that, thank you guys for watching. I hope you have an amazing and a beautiful day. Don't forget to head over to One Voice Odyssey podcast and just comment there and just say you are from mobile decks or you are from my tech channel. Let me know. Let me catch you all guys on there. And yeah, bye.